fire seasons are already longer, it's hotter, it's drier, the fuels are drier. That starts becoming the perfect storm, so to speak. Dry fuels, layers of fuels, 1 acre connected to the next, connected to the next, connected to the town. We can mitigate the intensity of the burning through regulating that fuel matrix. And we can manipulate that with any number of standard forestry procedures, cutting gaps, thinning out the stands to create lower density stands. On these restoration lands, the objective is what we're leaving behind, and therefore what goes out on the truck can range from very small to very large.
This is not the best quality fiber that you can find in the forest, so using them as building material is not immediately easy.
The whole question mark of the project is how are we going to use this material into something more useful.
So on the material engineering level, you need to figure out how to build panels of predictable engineering characteristics of this low value material. The problem is that this type of lumber has not been considered for structural uses before. So there is no documentation of what are the mechanical characteristics of the lumber being produced out of these thinnings.
We made a model to predict the design values of our CLT panel. Based on the comparison, we optimized the layup and fabricated prototype CLT panels in Emerson Lab.
If you think of mass timber panels, this is like a large panel where the structural responsibility is being dispersed on a large cross-section. You don't have to put your best fiber in this panel for it to be good for structures. And if we can predict them accurately, then we can tell engineers, this is the property, this is the panel that you can use for certain uses that do not require properties higher than that.
In this project, we wanted to explore the possibility of using modular components, and our CLT panels are the basic modular components of the system.
You can make a studio if you want to. You can make a 1-bedroom apartment, a 2-bedroom apartment, 3-bedroom townhouse, or whatever you feel like.
So walls and floors are the components that are made to stock, that are available on the market when needed, with a construction system that allows for rapid construction.
You can basically have these guitar parts, transport it to an emergency situation, build it up, then people are going to live there for a month, and then you basically dismantle them, flat pack them in a truck, and then move it to a next site where it's in need.
If you move towards modularity, repetitive units that are being used in inexpensive or affordable projects, this allows adding scale to the industry that we're missing this part. And the expectation is that the scale is going to drive the cost down as well.
There's a byproduct that comes from that forest restoration, and those are small logs, small trees that have to be removed. And technology has improved to a point where we can take that and convert that to 2x4s, 2x6s, and 2x8s. And we can now, with the advent of mass timber, bring those together into large elements. We manufacture pieces that are up to 60 feet long. All these products can be made to build very large multi-story buildings down to a sauna, if you will, on your property. And we've done projects of all types.
We are going to use the material that is causing the wildfires, making the forest safer, putting this through industrial process, and then using it. If it drives cost, it will allow more projects to happen. And this will allow more of this low value material to be used. So it is a cycle that feeds itself. Not only you make the environment better, you make our part of the world safer, and you're going to address a couple of perennial societal problems in the same time. Isn't it beautiful?